Hey everyone, welcome back to Lazy Man's Hardware, and today we'll be having a look at Karnaugh Map or kmap's POS form. As I mentioned in the last video that kmap is of two types, which is POS and SOP. We looked into the SOP form in the last video, and this video will be looking at POS, which basically stands for product of sum, which is of this type. Basically, you add the sum and then multiply the sum, basically product of sum. And in this video we'll be looking at a question, and before that I think you remember the criteria or how you can identify a POS kmap or SOP kmap. So as I already said in the last video, if you have a pi in your question, it's basically a POS kmap, and in that kmap you need to substitute 0. But if you have a sigma in this place, it's an SOP expression, and you need to substitute 1 in place of the minterms. Now let us dive into the question. So what we essentially have here is a POS kmap expression, and we have the following function variables a, b, c and d, and we have the minterms from 0 to 14. And first of all we need to check the type of kmap, and we have three types of kmaps, which is for the basic stuff. It's three types. So it's 2 variable, 3 variable and 4 variable. As I already said in the last video, if it's 0 to 1 it's 2 variable, if it's 0 to 2, 0 to 7 it's 3 variable, and it's 0 to 15 4 variable. So if you find anything that's in the range, then it's the type of variable kmap. So the highest term we have, highest min term we have right here is 14, so it's a 4 variable kmap, and we have to draw the 4 into 4 kmap essentially. So we need to substitute the variables in the row and column areas of each cell, and let us start substituting the min terms. So we need to before putting the min terms we need to mark the locations and the cells. So let us get started. Just follow with me. So 0, 1, 3, 2, 4, 5, 7, 6, 12, 13, 15, 14, 8, 9, 11, 10. So that's the thing. It's basically the same as the SOP term. So let us get started with the min term substitution. So we need to substitute a 0 at 0th position, and at first, and then the 8th position, and then the 9th position, then the 6th position, and the 7th position, and then the 14th position. So we got our min terms sorted, and now we need to go for the grouping. I already told you in the last video that we have three types of grouping, that is dual, quad, octal. So in dual we basically map two adjacent minterms, and in quad we map 4 adjacent minterms, and in octal we map 8 adjacent minterms. So so have a look at the kmap right now, and let me see if you can find any adjacent stuff. So as a beginner, if you haven't watched the previous video, you will almost come to a conclusion that these two are duals, but you're wrong. I already told you in the last video that these two are adjacent to each other, and these two are also adjacent to each other. So each end of a kmap is adjacent to the other end of the kmap. So instead of taking a dual here, we'll be taking a quad with the last two. So let us start the grouping. So let us group these and these. There we go. We got our first quad. Now let us check the other minterms and see if there is anything common to group them. So you can basically see that there are 3 minterms which are almost adjacent to each other. So what do we do here? We can't keep you can't take 3 elements at a time, nor you can take diagonally. Diagonal is, I think, Some of the common mistakes that people who do is some people may take these as diagonally, but this is absolutely a blunder. You should never take it diagonally. You should always consider it longitudinally or lateral, longitudinally or something, horizontally or vertically. So we have three elements. What do we do here? So what we could do here is we basically take a common min term for both. So this thing is in the middle, so let us take two duals. Just have a look at it. There we go. That's our group. So we basically took a common min term for both these, and we basically managed to map every min term in the kmap. So let us look into the formation of POS equations. So let us consider this grouping first. Consider G1, and what we essentially have here is we need to look at the common terms. So looking at the common terms, look at the variables in here. So both of these have b bar in common, so write b bar plus, remember POS is of this form, so we need to put plus between each min term, which between each SOP POS variable. So the next group is this one. No, we still have something. So we still have these in this column to check, and here we have C bar and D. Both of them are common, so let us put them into the equation. So we got our first group's POS equation, or basically the part of the POS equation. Now let us look at the second grouping. Now let us check what's common here. So we have this is a B bar. Sorry for the cutoff. So we both of these have this a plus B bar as common, so put that in. And then if we check this part, we have C bar as common in both of these, so put that in as well. So we go to a group 2's part of this POS equation. Now let us look at the quad that we have taken and consider G3. Now looking at G3, we can notice very fewer groups. So both of these have B as common, so let us write B plus, and checking this side we have C as common, so put C. So that's it. We mapped all the groups and we formed the POS derivatives. Now let us actually write the final POS equation. So there we go. The final POS equation is B plus C. I'm not writing it in an order. No, it's not a problem if you don't write it in the order. I'm just writing it. So this is our final POS expression. So this is it. This is basically how you can do POS with a kmap. Thanks for watching.